Oh, you didn't expect that one. Hello and welcome back to Calculus 1. I didn't want to disappoint. Mean value theorem. It is interesting concept. This theorem guarantees that on the closed interval, where the function is differentiable and continuous, you are going to have at least one place, one spot, one point where the secant line has the same value as the tangent line, at least one, which says, in terms of, let's say, speed, that the average speed is the same as the instantaneous speed. So I would, before I put the theorem down and we do some of the boring math problems, let's see some of the, I don't know if you want to call it interesting problems or not. So here be the highway. We're going to put a bush over here. Hey, in green. It's a bush. And another bush. So I have two of these. Then we're going to put this. And we're going to put another one right there. Don't worry. They're here to serve and protect. Perfect. Now, they're measuring the speed. And what's happening now is a car equipped with radar detector and everything else, right? We have, let's say, speed limit posted at 55. And since the radar detector goes off, the car goes 55 through this one, and later on goes 55 through the second trap because the radar detector again went off. And then within 2 weeks, got the ticket in the mail. How and why? Let's say that these two patrol cars were 5 miles apart. Let's say that this particular car was here at 1:04 p.m. and passed the second one at 1:08 p.m. Do we all get it? Yeah, we do, right? So what happened here? Well, we know that the velocity or speed is distance divided by time. And what I have here is that the distance between these two is 5 miles divided by 4 minutes. Now, we don't do miles per minute. So we take our 5/4 miles per minute and do the unit conversion, which you all love from your physics and chemistry classes, where you say, I want hours, so 1 hour has 60 minutes, right? And you cancel 4 and 60, and you get 15, and 15 times 5 is miles per hour. So, the average speed that this car had between the first track and the second track, all right, the average speed is 75. Went with both of these at 55, which is 20 off, so this car is probably doing 90 at some point here, or maybe even more, right? So this theorem will say that this car went at least once 75, because clearly, right, the average speed is 75, and if the average speed is 75 and you went to both of these 55, you have to be going more as well. So this car went at least twice, but you know, let's just say one is guaranteed. 75 miles per hour at one instant is guaranteed. And this is what this theorem does. Establishes connection between the average rate of change, which we learned a long time ago, and instantaneous rate of change, and this is application. How do you put this to use? Do you actually have cop cars doing this? No. Right? They measure and then wherever they catch on the instantaneous one, because they can only ticket the instantaneous one. Now, can this be used? Yeah, easy fast. Very simple. Log on the first gate, because you have to pay, right? It's your unique number that takes off your account. And then when you pass the second gate, there's the time and the same account. So did it go over the time that is allowed by the speed limit in between? Yeah, and then you just have if-then statement to mail the ticket. You don't even have to have people anymore there.
You might have to count the traffic.
Don't worry about the traffic, because traffic will never get you to speed.
Talking about the other way
I have never heard of the incident where you were stuck in traffic at 100 miles per hour.
Oh, no,
like you couldn't slow down, you know. I don't think that's going to be an issue ever.
I'm saying, like, what if it doesn't catch people who do speed because they were caught in traffic at some point? Yeah.
No, there's no on the way home. It's just gate to gate. There's no return trip here. It's one way. You have 2 points to compute. You're done. Now, what are the other ones? You have 2 accounts to swap right for the other gate. You can do that. Oh yeah, you can drive 200 miles per hour to the gate and then park there for 10 minutes. I know. Like, all right, 3 more seconds, go. Drive 20 through the gate. Yeah, it's good.
Yeah. But what if like the government just like changes our entire infrastructure and like I don't know, puts like a speed tracker on?
Let me just remind you that autonomous driving is upon us, so all of this is irrelevant.
Yeah.
Tesla already rolled it out, full version. They had the half version so far, and what, like a month ago or so, they rolled out the full version. So now you literally just sit in the car, say where you want to go, and fall asleep.
What if you hack your driverless car to disobey traffic laws?
Just don't do that.
Yeah. Oh, I'm very aware. I'm saying.
All right, so what's the formula that we all want to know and enjoy? That the average is going to be equal to, well, actually, no, they use B and A. Is going to be equal to derivative at some C, where this C is between A and B. There we go. That's it. That's the concept. This is ugly box. I have to redo this. What's the wording? It's triggering me. There we go. The ugly box. All right. I hope you're not disappointed, because yes, that's it. But let's see. let's see a problem. Say it says the function is ln 2x on interval 1 to e. What are we looking for? Find the point where average equals derivative. Yeah, quick. So we do exactly this. We have ln of e minus ln, ln of 2e minus ln 2 divided by e minus 1. And we are asking ourselves, the derivative of this is 1 over, if I just put 1 over c, would that make sense? Obviously not, right? Because I didn't explain much. So f of x is ln 2x. The derivative of this would be copy 2x and then its derivative on top, which is 1 over x. But I'm looking for that value c for which this equation will be true. So plug in c there. ln 2e, that's a product. So I have that as ln 2 plus ln e minus ln 2, they die, over e minus 1 is equal to 1 over c. That's 1. So 1 over e minus 1 is equal to 1 over c, from where c is e minus 1. Yay. So this is the value inside the interval 1 to e for which the slope of the tangent line and the slope of the secant line have the same value. E minus 1. X equals e minus 1. Now you can go and get the decimals and all that kind of stuff. You can find the tangent line if you want to. But the mean value theorem is the one that establishes this equality between the two. Let's do one more problem. These problems are very straightforward. Whatever. Let's see. 18, 22, 24, any? 18 it is, okay. Maybe I should have picked that one because they had trig. You like that. Sine 2x, 0 to pi over 4. All right, go on. Enjoy the problem. Yes.
The natural log of 0 is
Negative infinity.
Exists. So can this really be computed, or
Now, where do you see natural log?
that over? Oh, I'm sorry.
3 minutes left, and then another 10 after that. Seconds and then another 9 minutes after that. Let's take a look at this. So we start with 3 sine of 2 times pi over 4 minus 3 sine of 0 divided by pi over 4 minus 0. F prime is 6 cosine 2x, which means that on this side we have 6 cosine 2c. Right, we're looking for that c value that is between 0 and pi over 4. So sine of pi over 2 is 1. So I have 3 minus 0 over pi over 4 equals to 6 cosine 2c. And that's 12 over pi equal to 6 cosine 2c. From where when I divide by 6, I get 2 over pi equal to cosine 2c. Now, we have to solve this equation. How do we solve this equation? Nah. If we flip one side of a fraction, we flip the other one. Yeah. But actually, you don't have an inverse secant on your calculators, right? Yeah, you don't. Then apply inverse cosine there. Yeah. Inverse cosine. So cosine inverse of 2 over pi is equal to cosine inverse of cosine 2c. These guys cancel. So c is equal to 1/2 cosine inverse of 2 over pi. There it is. That's the answer. Now you can get decimals if you want to. If that's your preference. Word problem. We have 1 minute left and another 5 after that, so we can do a word problem. 35. I love this. 33. Mean value theorem and the police. 34. Mean value theorem and the police again. And then there's like, the return of the mean value theorem with the police this time. 35. No police. It says running pace. Well, it might have involved police, but it says explain why if a runner completes a 6.2 mile race in 32 minutes, then he must have been running at exactly 11 miles per hour at least twice in the race. Explain why if a runner completed 6.2 mile race in 32 minutes, had to be running at exactly 11 miles per hour twice. Maybe more, but at least twice. What now? This is a good exam question, right? You will write the paragraph.
Can you explain what 11 mile per hour twice means? It sounds like it could be multiplied by 11.
Just think about it for another 22 seconds.
End up doing a lot of work, but then he shows us that it's like 3 steps. Is it?
All right. So speed is the distance divided by time, which is 32 minutes. Oops. So we go cancel minutes, turn into an hour. And what do you get? I'm sorry? Yeah. There you go. Done. The average.
Is that what it was asking for?
Yeah. The average speed was.
Yeah, no, I just didn't know what the question was asking.
It's asking to add why you immediately have to go twice, right? When you start running with a 0 speed and you go up and up and up and up, right? Faster and faster and faster. So that means that you will be running eventually over 11 miles per hour. And then
He slows
you
down
actually
as
have
he
to
reaches
stop.
the end.
Yeah, you actually have to stop after the race is over. You don't keep running.
You don't know his life.
I actually do. I know this runner. So, she told me a lot of cool stuff about what it takes to be there. All right, stream. We'll talk again at some point.